on climate data.
Maybe just the first page.
Yeah. Yeah, tomorrow. Sorry. Maybe.
Yeah, we have.
He's online, I think.
And also.
Yes, she needs it here.
Good afternoon, Roberta.
She's online.
Okay.
Hey, you.
Good, good. And you, how are you? All good?
Hey, nice to see you. Good. Yes. Yes.
Nice to see you too. So we have still 5 minutes to start, right?
Yeah. Hey, Iman, maybe before starting, just because I'm going to send a message to you and Safar, but are we planning to have something during the IRENA assembly as well?
About
For
this
report?
no, actually, we didn't plan it because we have some urgent topics, that have been selected by the members.
Okay.
We have some discussions about AI, right? Ministerial, and
Okay.
it's more. But I will discuss with him.
Sorry, we can hear you in the pavilion.
Oh,
We can hear you when
okay.
you're talking. Sorry.
Okay, we stop. We stop. We talk later. Thank you.
Thank you.
Thank you everyone for being here. We will start soon. I'm waiting for it to turn into 30. It's 29. Cool. It's your first time to be the pavilion? Very nice to meet you. Let's start. Okay, it's time. Let's start. Good morning. Also, good afternoon and good evening because we have online participants here. My distinguished the delegates, the colleagues, also our panelists and moderator. Thank you for being here and online to attend this WMO side event. So our topic is climate data to action, enhancing the clean energy resilience and mitigation. So my name is Danfeng Zhu. I'm the delegate of COP 30. I'm also the founder of the Climate Voice Network. Thank you for joining. So before we start, we will watch a short video. It's about the climate and energy from the WMO. So it's 1 minute like that. So please play it. Thank you. Thank you so much. So now I want to talk about the rationale before this side event. As the climate change accelerates, actually our renewable energy system, the uh, they faced a lot of risk from the drought, from the flooding, or from the shifting the rainfall pattern. So this by this session, we want to explore how the climate services can help the countries to use the data to mitigate the risk from the climate change, to ensure the safety of our renewable energy system, and also to strengthen the system's resilience for a sustainable future. So I will have a brief introduction, like how this session will going. So firstly, we will have the opening remark from the Deputy Secretary General from the WMO, also the Deputy Director General from IRENA. So it will be record video. After this video, we will have a keynote from the Alberto Tracconi. He will join us online. So the topic is about when the weather shapes power, 2024 insights on the climate impacts on global energy system. And after this, we will have 3 minutes panel discussion. Our moderator will be Silva Goit, and we have distinguished experts from different organizations. After the panel discussion, we will have final minutes for Q&A. The question will be open to audience here and also online. So let's listen to the opening remark from the Deputy Secretary General of WMO. Yes, Cole Barrett. Please play it.
Distinguished delegates, colleagues, and friends, it's a pleasure to welcome you to this side event here in Belém at what President Lula has rightly called the Cup of Truth. Just a few days ago, the United Nations Secretary General reminded us that the 1.5-degree limit is a red line for humanity, and that while the risks are immense, we have never been better equipped to respond. That message captures the essence of this moment: urgency, yes, but also capability and hope. The World Meteorological Organization's State of the Global Climate 2025 update, released on 6 November, brings the evidence into sharp focus. The year 2025 is likely to be among the warmest on record, continuing an unbroken streak of exceptional heat for more than a decade. Behind every data point lies a community disrupted, a livelihood lost, or a dream deferred. Yet, our report also reveals growing resilience. Nearly 2/3 of national meteorological and hydrological services now provide tailored climate services for agriculture, for water, for health, and increasingly for energy. This growing climate intelligence is transforming how societies prepare, plan, and power their futures. That is precisely why we are here, to launch the WMO IRENA Year in Review on climate-driven renewable energy resources and energy demand. Now in its third edition, this report exemplifies how science and policy can work hand in hand. It shows how climate variability is reshaping the energy landscape. Extreme heat driving electricity demand 4% above normal. Drought reducing hydropower, and wind and solar performance fluctuating sharply across regions. But this story is not only about risk. It's also about readiness. The same science that warns us can also guide us. Seasonal forecasts can anticipate energy surges months ahead. Climate services can support cross-border grid planning. Reliable data can unlock investment and de-risk projects, particularly in Africa, where renewable potential remains vast. This is what we mean by climate intelligence, transforming data into actionable insight for a cleaner, smarter, and more resilient energy future. I wish to thank Director General Francesco La Camera and his team for their partnership and leadership. Together, WMO and IRENA are building a bridge between the atmosphere and the energy grid, between data and decisions. As Antonio Guterres, the United Nations Secretary General, has said, we must stand with science, stand for justice, and stand for future generations. At WMO, this means ensuring no country is left in the dark without the data, forecasts, or capacity to make climate-smart energy choices. And as we move through this decade of implementation, climate science must guide how we shape and sustain the energy transition, ensuring it is fast, resilient, just, and informed by science. Thank you.
Thank you. Thank you so much for highlighting the WMO's leadership in advancing climate services for energy system. So now let's hear, we also have the opening remarks from the Deputy Director General from the IRENA. So yes, let's welcome.
Distinguished guests, ladies and gentlemen, it's my great pleasure to welcome you to the session on climate data to action, enhancing clean energy resilience and mitigation with climate services, organized by the World Meteorological Organization, the WMO. Unfortunately, I cannot join you all in person, but I'm pleased to share my views via this video message. This session focuses on how climate-informed renewable energy strategies can enhance clean energy resilience in the face of growing climate variability. It also unveils the third edition of the report 2024 Year in Review Climate Driven Global Renewable Energy Potential and Resources and Energy Demand. This report deepens the understanding of how climate variability and long term changes are shaping renewable energy resources and electricity demand worldwide. It is also a testament on the ongoing collaborative efforts of two leading organizations dedicated to shaping a sustainable future, the WMO and the International Renewable Energy Agency, IRENA. IRENA's message is clear. The global energy transition is accelerating, but the opportunity to meet the goals of the Paris Agreement and keep the 1.5 degrees centigrade target within reach is closing rapidly. At COP28, the UAE consensus charted a bold course to triple global renewable capacity and double energy efficiency by 2030. Our analysis indicates that this goal remains within reach, but only if we can take decisive actions in the second half of this decade. To date, our data reveals a positive pattern. In 2024, the installed capacity of renewable power capacity grew by 582 gigawatts to reach 4,400 gigawatts. Solar photovoltaic and wind energy continued and accounted for two-thirds of this growth. However, as this report underscores, the success of this transition increasingly depends on understanding how climate variability affects both the supply and the demand for energy. To stay on track, we need to, and on an average, have about 1100 gigawatts of renewable energy annually till 2030. The good news is that last year, 91% of the new renewable projects were cheaper than fossil fuel alternatives. Renewables have proven that they are economically viable, and now we must deepen our understanding of how climate data and apply it effectively to the various aspects of energy transition. Our joint analysis indicates that climate variability represents a strategic risk for clean energy transition. And today's discussion is crucial to enhance our understanding on how climate impacts the supply and demand of renewable energy. It is essential for policymakers, energy planners, and resource managers, as well as power utilities worldwide, to have access to comprehensive data and analysis. This will enable them to fully grasp the extent and patterns of variations observed in resources and the demand. So it will help in improving our understanding of the climate drivers, and their interaction with renewable resource is vital for resilience, for efficiency of the energy transition and systems. IRENA and WMO will continue to collaborate and share knowledge on the links between renewable energy resources and weather and climate conditions. I'd like to wish you a very productive discussion today. Thank you.
Thank you, WMO. Thank you, Arona, to say the stage so clearly. So their message tell us the climate resilient energy system is not optional. It's kind of foundational for our climate resilient society, for our development strategy. So now we are going to move into our keynote part. It's a keynote presentation. So it's my pleasure to introduce our speaker today, Alberto Trecconi. So he is the co-founder and also the CEO of the Inside Climate Science, and he is also the managing director of the WEMC. So WEMC, which means World Energy and the Meteorology Council. And he also is the chair of the WMO study groups on renewable energy transition. So Alberto is joining us online. Ebodo, the floor is yours.
Thank you very much, Chair, for the kind introduction. And I just want to make sure that you can all hear me and see the
Yes.
slides.
Yes,
You
we can
can.
hear you clearly and we can see the slides.
Excellent. Thank you very much. So thank you very much for the invitation to present at this important event at COP30. And I'm sorry I'm not there in person. It'd be very nice. That'd been very nice to be there with you. And I'm looking forward also to the discussion after this presentation. And it was very also nice to hear the words of the WMO's Deputy Secretary and Irina Deputy Secretary General. And I'd like to thank, before we start, also the contributors to this report that I'm going to introduce. I'll present some highlights from the report that has been mentioned. The contributors come from the World Energy Meteorology Council and Inside Climate Services, as well as World Meteorological Organization and IRENA, for whom I thank the support as well throughout the preparation of the report. And this is, like, as we said, it's the third edition. We've had also several reviews. I would like to thank that have provided great feedback to improve the content. So the outline of the presentation is as follows. We'll go through some fundamentals first, briefly about the connection between energy and climate. We then look at some of the ambitious plans that have been put forward over the years, and also what is the current energy mix and outlook in terms of renewable energy particularly. And then we delve into the report and some aspects of the report. And particularly, I will present what it shows overall and how it can be used in practice. So if we look at the connection between energy and meteorology, or energy, weather, and climate in general, they are very closely connected. And this happens at all the timescales they operate in. So if we look at the past climate is closely related to the planning and financing that is done in the energy sector. And when we look at the future, there are different timescales that are available through the weather and climate community. And these are to do with short-term weather events. So the weather forecast that you see every day on television, as well as longer ranges that go to weeks and even months, and now even multi-years. And to go to the climate projections, so the long-term decades and a little beyond. So each of this timescale is associated with a particular aspect of the energy sector. In the short term, the short-term forecast normally are used for operations, and then the monthly forecast for maintenance, and seasonal forecast for management, and finally climate projection for investment and planning. This is just a broad definition. There are obviously some overlaps between the categories here. What I want to highlight is that in this report, we particularly focus on the past. So the main focus is looking at what happened in the past, and particularly a specific year, 2024 in this case, but also in the context of a longer term average and the previous years. However, we also provide some indications of what forecasts can do for managing the resources in energy, and this is through this what is called seasonal climate forecast. So we'll touch on that as well. In terms of plans, just to give you an overview of the global scene in terms of electricity, I think it's important and interesting to remind us what some of the great plans and ambitious plans that been put forward, starting from the Desertec, which this started in the 1970s. Unfortunately, never took off as it was planned, but actually a lot of the components that have been envisaged 50 or more years ago are now being implemented, even though not in its entirety. And more recently, GEICO, the Global Electricity Interconnection Corporation, put forward this map where there's a possibility to connect everywhere in the world with the grid, electricity grid. And the implication of this is, of course, that with the increase in capacity in renewables, all this grid will be fed in large parts by renewables. And so the implication is that the more renewables there is, the more connections, the more exposure to the changes in climate there are. And that's where it's really important to look at what happens to the climate to understand how these various parts connect with each other, even in the shorter, smaller frames within Europe, for example, or the US or China. There are variations that can be exploited in order to balance the system in a better way, knowing what happens to the weather and climate. In terms of, we heard from the IRENA Deputy Secretary General about the latest increases in renewable energy. Particularly important is the increase in PV. Solar PV, as you can see, has now surpassed in terms of capacity, installed capacity, the wind power. Not so much in terms of generation, but it's reaching that level also in terms of generation soon. And we can also see in this slide here, when we compare, this is a table that is available in the report, we compare the 2024 with the previous year and also 10 years before, and it's staggering to see, like in terms of solar power, the increase just in 1 year, there's a 32% increase and 730% in 10 years. So a very large increase, and with a target of about 1,500 gigawatts for 2030, this would be easily reachable with the current trend of increase in the last year. So and we also show all the other figures here. We won't go into the details, but like I said, it is going to be available in the report. Now, going into the report in terms of specifically the indicators and the variability that has been reported, what we have in the report is a collection of 4 energy indicators. These are some proxies that show how wind and solar capacity factors vary over time, as well as a precipitation-based hydropower proxy and the temperature-derived energy demand proxy. So we have 3 generation indicators: wind, solar, and hydro, and 1 demand. And the idea is to try to balance them. Obviously, they're not the only generations, but often we look at how the 3 compensate with each other. And the report allows to do some of this analysis, as we will see. And like I said previously, the report compares particularly 2024 conditions to a 30-year climate, which is the standard 30-year 1991, 2020, that is taken in climatological world. And then we quantify the anomalies and highlight the implication for energy systems, both globally and regionally. And we analyze this at the annual level and as well as monthly variability. And like I said before, also we look at how seasonal forecasts can aid the management of resources. So how to use this? We'll go now from the global to the regional picture. So the idea is that we start to see what the implications of the variability in these 4 indicators, climate-driven 4 indicators. So as a reminder, these indicators are essentially driven by climate. There is not technology input or economic input in this indicator, so purely climate driven. And we can see that when we compare the last 3 years of these anomalies, these are differences compared to the 30-year mean, and each year compares to the same 30-year mean. We see the variations that are quite large. Numerically, it's only between, let's say, 4 and -4, -5. However, this is a global number, and so it's expected that the number would be small because it's averaged over a large area. But if we consider, for example, a 2% decline in global wind power capacity factor through some conversion, we can then relate this to the actual consumption of electricity for households. And globally, if this change was uniform across the globe, with the current installed capacity of 1,000 gigawatt, this change would, if it was an increase, it would increase the electricity for 10 million households and vice versa. So this large number, like I said, the numbers you see here average out over the globe. And so it's important to look at what happens at the more local scale. So the next step is to look at some more regional results. And this is what we've done here by breaking down the globe in various standard regions. And here I put some examples of what we see in the images without going to the details of each one of them. So if we start from the left, we highlighted the impact of the variability in precipitation and therefore hydropower in this case. And for Central America and Mexico, where there's about 20 gigawatts of installed hydropower capacity, this would be equivalent to an electricity consumption of 3.5 million households, with the anomalies of 20% that we've seen year to year. In the case of East Asia, for example, we have a 5% anomaly in wind power capacity factor, which would result in a change of electricity for 15 million households. And lastly, in terms of solar power, you see variations. Normally, variations in solar power are considerably smaller than particularly wind, in the case of wind power, for example, because of the lower baseline of the capacity factor of solar. And in this case, 2-3% still has some impact in Oceania, particularly that results from the 40 gigawatt installed in Australia, and which would affect 250,000 households, roughly 2-3% of the Australia's population. So these are relatively large changes over a year. And these changes become even more important when we look at the finer temporal scale. So the next part of the report looks at individual indicators. For the 4 indicators that I mentioned, I will briefly show these maps without, again, going to the details of them. They're all available and discussed in the report. And I highlighted also a region here which will delve a bit deeper in the next part of the discussion and analysis, which is Western Africa. And here we show the annual values, and then we also highlight 2 particular months, no particular reason, but just to show that there are variations, obviously, also at the monthly level, and normally much larger than what happens at the annual level. And that's why it's important to consider these variations month by month. And of course, if you went to finer temporal scale, the changes would be even higher. So that's why it's important.
Sorry.
So we're looking at changes of
Sorry,
yes.
Boto. Because of the time limit, we would appreciate if we can, a little bit quick. Thank you.
Yes, yeah, sure. So we then go, like I said, quickly through the 4 maps. So solar power capacity factor, hydropower proxy, and energy demand. So I just wanted to show you how this can be also used when you go to the finer scale, so country level. In the case of Western Africa, which is just representing 4 countries for the facility of displaying the countries. It could be done for more countries. And in this particular case, the countries also are part of the Western African power pool, so there are interconnections between them. So what we do also in the discussion is to look at how the variations month by month and also country by country and generation by generation of demand are connected through the countries and through possibly the connections that are existing here. And finally, the seasonal forecast, like I mentioned, this is an indication of, this is available for the 4 indicators. Here I only show the wind power and energy demand, just for facility of showing this, having fewer maps. And here we have the discussion around how the El Niño Southern Oscillation, which is the largest climate variation in the globe, affect the variability in Africa. And particularly El Niño was still active in the early part of 2024, and then it dwindled and waned after that. So here are some take-home messages. And I just read the first top line, and then I'll leave it to the rest of the discussion. So the climate variability is reshaping energy systems. Planning must keep pace with it. Data and forecasts are critical enablers of climate smart energy decisions, and regional context matters. Empower countries with tailored tools and insights. And thank you for your attention. Over to you, Chair. Thank you very much.
Thank you, Alberto, for this great presentation. Because of time limit, we cannot do Q&A. So we know the climate, the weather, it cannot be just the background noisy. It should be the core parameter for the energy planning and also the risk management. So we will start our panel discussion. Our moderator will be our Silva, and hand over to you. Thank you.
Thank you very much. Thanks for being here. I know it's a challenge with the competing events going on around us. I hope you bear with me and the level of noise that we hear everywhere. I don't know who is there. I think it's the German pavilion, making a lot of noise. Thank you for being here. My name is Sylvie Goyer. I'm Deputy Coordinator, Head of Environmental Activities at the OSCE, the Organization for Security and Cooperation in Europe. Now, the OSCE has a comprehensive approach to security, including the dimensions of political military, the classical security sector, human dimension, but also economic and environmental issues. We view economic and environmental challenges as security challenges. What we just heard about uncertainty in energy supply is to us clearly a security challenge. Now, we're delighted to work with, no, that's okay. I have it. Thank you. Now, we're delighted to work with WMO and IRENA on furthering some of the outcome of this report, and very happy for Alberto for presenting it. Now, without further ado, I'd like to introduce the panelists. We'll delve a bit more into some of these key issues. Alberto reminded us at the end. In particular, I'd like speakers to please focus on data in terms of variability. How do you focus on that? How do you factor variability in deploying renewable energy? And again, the importance of data and climate science. Let me welcome the panelists. We have a great lineup of speakers. I'm very honored to have them here in the room and then online. Yes, you have the pictures. Let me invite Kiwan Riai. I hope I pronounced your name okay. You're the director of the Energy, Climate and Environment Program at the ISR, the International Institute for Applied Systems Analysis. We work very closely with you. I'm very happy to have you on board. Virginie Schwartz, you are the CEO of Météo France, something I listen to every morning, and the permanent representative of France to the WMO. Thank you for being with us, Virginie. Elena Alexandra Miron, You're the 2025 Clean Air Task Force Fellow and Researcher at the Energy Policy Group, also from Yango. Elena, please, wherever you wish. I mean, I'm going to be standing if that's okay. And Jose Ignacio Martinez, I'm going to skip the last part of your name. You're CTP Officer, Multilateral Coordination and Analysis at the IEA. Thank you for being here. I'm not forgetting our two panelists online. I hope you're there. Please wave if you are. Vincent-Henri Peuch, member of the ECMWF Directorate and head of the ECMWF Bonn site. I hope you're online. I'll come to you in a minute. Well, I hope he is. And Imen Gerburg, team lead on the Renewable Energy Resource Assessment at the IRENA, International Renewable Energy Agency. I saw you earlier, I guess. I hope you're there. Thank you. We have little time, as you heard, so I'm going to ask you to be as specific and concise as possible in your response. Let me start with you, Kiwan. At ISI, you clearly excel in developing some of these global integrated models and assessment. And you've seen in the data that was shown, it highlights considerable shorter variability in the trends. Can you tell us a bit more how this kind of variability is incorporated in your model, in your work, to better inform resilience and robustness, please? The floor is yours, and I'll give you the mic.
Yes, thank you. Thank you, Sylvie, for the kind introduction. It's really great to be here. Thank you for having me. As already explained, so at IASA, we work on more aggregated global models who had to try to help us to understand the pace of the transformation. These models are also used in the policy context. Very often they provide benchmarks for critical system changes that are then discussed here at COP. So if you think about tripling of renewables, or if you think about phasing out fossil fuels and how quickly this should happen, very often information from the IEA and information from the integrated assessment models are used. Now, in order to increase the policy realism of our tools, it's important to be able to, it's important to be able to basically connect information across different scales. Our tools operate at a scale of 10 to 30 regions. They are informed by spatial analysis of important resource factors like those that we have seen here for renewables, where we take spatially explicit information about the efficiency, about the costs of those technologies, and try to aggregate them in terms of how much can be supplied in a certain context and in a certain region. So for this information is really critically important. We take into account the variability in terms of the load across the day. So usually there is more energy demand during the day and then less during the night. Energy demand varies seasonally. Yeah? So the difference between winter and summer is in most of the regions, also in terms of the potential of those technologies, still much bigger than the variability that we have seen. And this is taken into account as well. And how do we do that? We generally take information like those provided by IRENA and also by the WMO, and combine that information with information that comes from Earth system models into the future to understand how these potentials change on the ground. And we try to aggregate them up then into at a level where basically we can model the system integration. And there are different types of models there. So the integrated assessment, which are very detailed, but very aggregated. And these models are coupled to dispatch capacity models. So basically those who take variability of renewables into account and tell us something about how much curtailment will you have. So if you if you have a certain capacity, you build a PV cell. I don't know how many of you have PV cells on top of your on your roofs. You will know that if you don't manage that well, you will have to throw a lot of electricity away. And if you increase the variability, you will have to throw a lot away as well. So what we try to model is the interplay between daily and seasonal energy storage availability, the expansion of the grid, and the spatial characteristic of the resources that are provided by climate services that they have heard of. So absolutely critical information, even for the global aggregated models to get this right. So one thing that I would wish myself that we would do more, if I can express also a wish to the climate service providers now, is that we don't only look into the biophysical reality, how much solar radiation is coming in and how does it change because of its variability. If we look underground, most of the solar is not built there where we have the best solar conditions. Most of the solar is built there where we have infrastructure, where we can connect the solar panels to, and we need to understand that as well. And sometimes solar panels are not built because they are perceived as intrusive, aesthetically not appealing. And we need to do more analysis to understand what's the sustainable potential of those technologies. Where do we have these trade-offs with biodiversity? We need to understand where can we connect them most easily to the current system. And we need to understand where can we expand solar and it's still beautiful, if you wish. So we need a beautiful, sustainable potential of solar, which is, I think, a little bit smaller than the numbers that we work with at the moment. Thank you.
Thank you very much, Kiwon, and thanks for highlighting how you integrate this variability. Now, you've launched a call to really ensure that we don't only look at data, but we look at acceptability at the social and ground context, and I think that's critical. And that gets me to move to Virginie, at the CEO of Météo France. You're one of the meteorological services are the backbone of the economy and the key link between the data we get and the services you provide to customers, private companies, and individuals like you and me, right, watching what's happening. Virginie, could you tell us a little bit how Met Services and your service in particular work indeed with companies and public authorities to maximize the benefits of renewable energy and ensuring that this data is conveyed?
Thank you very much for having me this morning, and good morning to everyone. As the French National Meteorological and Climatological Service, the energy sector is actually our first sector in terms of private customers. And we deliver services, I think, in almost everything that has been talked about this morning. But because we only have a very little bit of time, I'll just give you a few examples to pinpoint how we try to make this data as useful as possible for our customers. First, optimizing operations. We have a number of renewable energy sites that are on the ground with the variability that is inherent to meteorology, but that can be increased by climate. How do we help them deal with it? Very close to here in French Guiana, there's a very large hydropower plant called Petit Saut, which provides 40% of the electricity of French Guiana. So it's absolutely critical. And we have been working for many years now with EDF, the company, and now they actually learned to do it themselves, to see how they can use seasonal forecasts for hydropower management, to see how they can optimize the use of the water, but also how they can work with the authorities in advance when we know that there's not going to be as much water as we hoped for, and that there might be some electricity difficulties on the land. To go a little bit further than that on how we work with hydropower companies, we've put our local climate projection capabilities to use to try and forecast what the impact of climate change could be for hydropower resources in France at the local level. So we have specific maps that we have generated, differentiating between what will happen when we're talking about run-of-river hydro or or with dam hydro to help with siting, and again with uh, thinking about the balance between supply and demand with renewable energy. Second example on de-risking. We know that with these uncertainties, it can be even more difficult for the operators that are building these new power plants, whether they're hydro, PV, or wind. It can be more difficult to get financing. What we are doing with a mandate from the French government is looking at the sites where the government want to have tenders for offshore wind parks. And we're doing all the analysis of the observation, so long observation campaigns to see what the resource could be in terms of wind energy. But also we're looking at the risks. So looking at climatology over very long periods to see how high is the risk of simultaneous waves, high swelling, strong wind, and submersions that might put at risk these wind farms. And again, that would be something that financiers may put a high premium on in terms of risk. And then you talked about previously the importance of balancing supply and demand in our larger transnational contexts. And this is especially true in Europe, where our electricity grids are very much integrated. And so we are lucky enough that we have different patterns of winds in different countries. We have different solar radiations periods in different countries, and this builds resilience in the European electricity grid when we're talking about renewable production. But when we look at science, we see that this resilience may be challenged by climate change. And so this is one of the examples of how we work very closely with our electricity transport system operator, the TSO, and we have a study on the occurrence of simultaneous low renewable energy production scenarios in France and in Europe to see whether in fact these risky scenarios are going to become more probable, which means we can globally in Europe expect less outcome from our renewable energy generation or not. So just a few examples.
Thank you very much. Very interesting to hear that the energy sector is actually your prime customer, and good to hear about the example of the hydropower in Guyana next door. And I particularly enjoyed the de-risking and aspects as well. Let me move to Elena now, and we've been talking a lot about data and science. And Elena, maybe I'd like you to tell us a little bit more how you see your role as a young researcher and professional helping move this data and science to the people. Thank you.
No, thank you so much. So the question that I had already was focusing on two very specific things. I am a young researcher, but also I am the youth delegate for my delegation. So I'm a part of the Romanian delegation here at COP, and not only at COP, but at home as well, because that's very important. And I also have this hat of YONGO, which is the youth constituency to the UNFCCC. So it is like a connection between all these three positions, but not only that, looking from a local perspective, national perspective, regional perspective to a global perspective for a young researcher, it just opens perspectives in my own research. I'm focusing, so within my research, I'm focusing on the Central and Eastern Europe region. I'm not exactly sure how much you know about the region, but it's quite a geographical strategic position for Europe. Not only that, in terms of energy, of course, and energy security, but not only that, it is a geographical position for a lot of potential in terms of how can we provide energy security to the entire Europe. And not only that, at the borders, we have something called a war between Ukraine and Russia. I'm not going to go into that. I have two questions that I have been given. One, what policy mechanisms do young people see that would work in terms of how can we create energy systems that are more resilient, adaptive, and inclusive? And also a question that is very I am very fond of is how do you see young professionals playing in enabling this transition? That's like a key. A key is not only about education and skills. It is about how can we make sure that the young people that we have now are not only just young people looking at the decisions are being made, but how can young people really be part and integrated in this? It is a very specific, we have a lot of young people, experts in the field of energy, but not only that, very technical engineers as well, but they have to be there where the decisions are made. And not only that, to provide the research and data for the policymakers to understand how the IPCC is doing, but in a summary version. So I would like to point out a few things about what I think these are like what I think the policy innovations could be. So we are looking at climate informed energy planning and decision makers. How can we do that? So we have a few recommendations from Yongo's working group. The constituency has a working group specifically on energy. Besides the fact that we want to have an energy negotiation track, that would be a very good addition to the negotiation tracks. Of course, energy is related to everything right now. But I would love to stress a little bit the ETF reporting that shows how parties are integrating science into investment decisions. I think data and investments go hand in hand. And this could be a way of innovating the policy mechanisms that we have right now. Another thing that we are looking into is enhanced transparency mechanisms to ensure that climate services are not used only in national strategies, because it's good to have, of course, national strategies, but also utilities, regulators, and operators. And I would go, because of the time, I would love to share a bit more here, but because of the time, I would go to the second thing that I wanted to say about the role of young professionals. Yeah, not even 1 minute. Across Europe and Romania, young engineers, researchers, and civic tech innovators are already filling governance gaps. We are mapping grid congestions, designing climate risk tools for local governments. We are trying to deal with decision makers at local level as well as central level. And then we want, or I think it's very important to highlight formal youth representation in national energy councils. We have them in Romania and not only in Romania, and youth inclusive NDCs as well. So, well, I would love to expand, but these are my thoughts. Thank you so much.
Thank you very much for your points. And let me reassure you, you're not just a young professionals, you are a researcher in your own right. And that's why we're here. Let me move on to IEA now. IEA, you're the global authority on energy policy and system transformation. From your perspective, can you tell us what would be the most practical ways to build climate resilience into the clean energy transition? Thank you. I have 3 minutes.
First of all, thank you so much for the invitation today to talk about this important topic. I want to make a special thank you to Roberta, that I know that she is connected because she has been supporting a lot, and especially in some events last week. But I want to start saying that last September, we host a high-level roundtable to talk about energy infrastructure resilience, where more than 90 people from 30 different countries, including minister, energy companies, insurance, convened to talk about this topic. this was built on our future energy security summit that we co-host with UK, where countries ask to us like to talk about energy resilience. And I want to start saying like that from IAA, we have been systematically tracking extreme weather events, especially like we launched our WEO report last week, the World Energy Outlook, and also we launched the Colombia Net Zero Roadmap. In both report, you can see a chapter where we were like, so we went deeply to analyze like resilience on extreme weather and understand the impact on energy sector. Also, IEA has published different national climate resilience assessments, which provide an in-depth review again and evaluate the current risk and future risk of countries and the impact in the energy system, and at the same time like identifying like measure to enhance resilience. This year particularly we have been focusing on Africa, specifically Algeria and Mozambique, and we will launch an assessment, a national climate resilience assessment on Kenya and South Africa. But I want to point out like data speaks volumes, which means that power sector is particularly vulnerable to this risk. Our new data report shows that in 2023, alone around 300 extreme weather events were responsible for power cuts of around 210 million households, and power grids were impacted by 85% of this event. As other panelists mentioned, hydropower is particularly like impacted by climate change. Also, we have been like working some reporting in key areas like Africa, South Asia, and Latin America, where assessed in detail how this region hydropower plant capacities could be changed in different scenarios. I want to highlight the case of Colombia, that is a country that relied a lot in hydro, but is affected all the time by El Niño and La Niña. Yeah, sure. But I want to like, so what we can do to build climate resilient. I want to highlight three main points. First of all, preparedness and prevention through better planning, improving monitoring, and early warning system. Second one, resistance and adaptation. There are like promising application of advanced data analytics on artificial intelligence, providing forecasting, like detection and operation in scale. And finally, recovery and response through stockpiling critical equipment, like pooling emergency resources, and like ensuring rapid restoration of essential service. And to finalize, three key message. Building resilient energy system means proactively designing for. Second one, resilience must also be inclusive. And finally, we must recognize that no country can do this alone. Thank you so much.
Thank you very much. That's a nice way to conclude it. And thanks to IEA for all the work you do and the reports that are really useful. Let me now move. I know we don't have much time and I'm being reminded, but let me move quickly to our two panelists online. Vincent Henry, if you're online, are you there? Are you there?
Yes. Yes, I'm here.
Can you?
I can hear you.
Yes, we can hear you. Thank you very much.
Excellent.
Please, the floor is yours. Can you tell us a little bit what recent modeling and data advances at ECMWF are most promising for operational use by the energy sector? You have 3 minutes, I'm sorry to say, but thanks for
Thanks.
being with us.
Thanks, and thanks for the invitation. So yes, in this day and age, we are all convinced that good decisions need good data, and the energy sector is no different. There have been already in this panel some discussions about how good data can influence managing demand and production in the sector. At ECMWF, our focus is on forecasting the weather beyond the next few days. That is from the medium range, 3-5 days, until monthly, subseasonal and seasonal timescales. And these timescales are, as Alberto Troccoli was mentioning, critical for the energy sector. One activity that we do at ECMWF on behalf of the European Commission is to organize the Copernicus Climate Change Service. And as part of that, we've been assembling seasonal forecasts from leading centers in the world, Météo France being one, ECMWF also, we do some. And some of our work has been to put them together and make them available to the wider community and particularly the energy domain. So what are the most striking advances, I think, of the last few years? The first one is actually to put together these data sets so that users can experiment these data about temperature, rainfall, wind, and it's not single figures. It's produced with a number of models. It's probabilistic. And just the research and development to play with these figures and to look how these figures can be leveraged and tailored to specific needs. Some users are very sensitive to missing extreme events. Some users are very sensitive to not detecting events. So this can be experimented, and we've seen a lot of activities there. The second area where we've seen a lot of progress is on showcasing example, good practices. Virginie Schwartz mentioned some hydropower example in French Guyana. We have one very interesting in Ghana with a reservoir on the Volta River. And there, it's not only the hydropower that the operators have to manage, it's also the conjunction with irrigation. So they use seasonal forecasts to before the season to forecast how much coal they need to buy so that they can serve both the energy demand and the irrigation needs. We have also lots of examples. One we will publish soon with Enel, one of the global leaders in the power and gas sector, how they integrate seasonal forecast into their gas demand planning. So lots of good examples that help progress. And the last thing I want to mention in terms of advances is the use of AI. AI is not only making things more post-processing of data more accurate, it's also changing the paradigm of the forecast for seasonal forecasts. So we are no longer integrating the equation of physics in time, but the AI is looking at patterns across timescales, and so there is a lot of hope that the skill of seasonal forecast, particularly in mid-latitude, where they are currently quite low, can be improved. And to finish, what I want to do is how to make climate and seasonal forecast more mainstream as a planning tool. We had a study that was actually commissioned from Alberto Troccoli and colleagues about the barrier to wider adoption of seasonal forecast. The first one is low skill, particularly in mid-latitude, and the granularity. When you go further in time, it's difficult to have information at the weekly or the daily granularity, which would be needed in principle. There are also difficulties in the form of these forecasts being probabilistic and not deterministic, so that the tools that are used for planning needs to be adapted to probabilistic information. And also, yes, awareness and training. So what we do in terms of making them more mainstream is to keep improving the forecast. And second, I would like to finish by saying that sharing data is very important, and the more data we can have from the energy sector, the better the community can work in developing a better model for the estimation of demand and production. Thank you very much.
Great, thank you very much. Oops, thank you very much, and sorry for that. I know we just have about 2 minutes, so I'll quickly go to Imen and then wrapping up with Roberta. Imen, it's not giving credit to Irina to give you just 1 minute, but I just want to underscore the work that you do and your responsibility in really tripling the renewable energy capacity. So please, in 1 minute, if you could give us a bit more of your work at IRENA and how you account for climate risks in your work. Thank you very much.
Thank you, Sylvie. Good morning, everyone. I'm pleased to participate in today's discussions. So to go straight to the point, that's true. IRENA has played a key role in shaping the targets of set under the UAE consensus. And we recognize that also the challenges extend beyond achieving these gigawatt targets. And we should they involve actually the system resilience because of the climate change and variability. I would just say that IRENA, with the help of its partner, is already helping our member state to estimate their energy targets through the traditional approach, the long-term energy modeling, or even the renewable potential assessment. And this is all conducted under the NDC's activities. But we are taking some steps to embed the climate dimension in our work. And we will keep encouraging countries, of course, to ensure that the investment decisions are climate informed and they are aligned with the tripling agenda. So that's in short to fit the 1 minute I was given. Thank you.
Thank you very much, Imen. We rely on you to do that, and we'll get back to you on all this. Now, to close the event with a bit of a forward-looking, I'm going to hand over to Roberta. Roberta, you got the greetings from everyone here on the panel, and I'll pass it over to you to close with forward-looking remarks, please.
Thank you very much. I think I have less than a minute, probably, and I just want to thank everybody, Danfeng, Alberto, Sylvie, and the distinguished panelists for this such rich and forward-looking insights. I want to say that this report is not ready yet, so this is an event that let's soft the launch of this report, but we hope we should be ready in 2 weeks, and I will inform everybody, all the community, through the channel of LinkedIn and the website, the IRENA and WMO website, when the report is available. Just want to say this message before we finish. There is no resilience, clean energy future without climate services, because the science is ready, the demand from the energy sector is growing. So thank you a lot to everybody today, on site and also online. And thank you for your commitment to build these energy systems. They are both clean and climate ready. And I look forward to continuing this work and this discussion beyond the COP30. Thank you very much.
Thank you very much, Roberta. As Deputy Secretary General